Okay, so let's begin with a brief review of some things from algebra. Obviously, solving equations is definitely going to be a really important part of your math career as you go forward. So let's just start with a quick recap of solving an equation. Obviously, what you want to do is you want to get all of your variables to one side. So I would obviously start by adding 5x to both sides. Once I do that, I combine my like terms. 2x and 5x together make 7x, and as I divide by 7, I find out that x equals 2. Okay, if I want to check myself, all I need to do is to take that 2 and plug it back in for x. You can do this in your calculator. Just do 14 minus 5 times 2, and you will find out that that comes out to be the same thing as 2 times 2. Okay? When it comes to inequalities, you're pretty much solving a lot like you would solve an equation. You just have to be mindful of if you ever multiply or divide by a negative number, that you'll have to flip the inequality. So this one's a little more complicated than the previous problem, but hopefully you remember from back in the day when you were solving equations, you always have to start by getting rid of parentheses. So as I distribute that becomes 2x plus 26. Notice I'm keeping my inequality the same. What I want to do is, again, I want to get all my variables to one side and all my numbers to the other side. Likely I want to try to keep my coefficient of my variable positive so I don't have to worry about flipping my inequality. So I'm going to minus 2x from both sides. I'm also going to add 6 to both sides. As I do so, on the left-hand side, I get 4x. I'm going to keep my inequality the same because I didn't multiply or divide by a negative number. And as I add 26 plus 6, that comes out to be 32. Dividing both sides by 4. I can leave this in the same direction. I end up with an answer of x is greater than or equal to 8. Now, unlike the first problem where we just had an answer of x equals 2, one singular answer, an inequality results in an entire solution set. So to represent this solution set, if I were to make a number line, I would put 8 on that number line. Because of the fact that that is greater than or equal to, I'm going to make this a filled in circle. And because of the fact that I'm saying all values that are greater than or equal to 8 are in the solution, I shade in all the values that are greater than or equal to 8. Okay, you definitely want to make sure you go back over solving equations. Feel free to try out these other examples, and you can check the solutions on Google Drive. If I go forward to the second page, just to recap a little bit of some laws of exponents. Again, all of this is conditional upon having things like the same base, especially for the multiplication rule or the division rule. So you'll notice that if I have two things with the same base and I multiply them together, I'm going to add their powers. If I'm dividing two things that have the same base, I'm going to subtract their powers. I would say that's pretty important. When you're raising a power to a power, they get multiplied. Okay, so be careful. Obviously, there's a difference between this one, you're raising a power to a power, whereas this one you are multiplying. When you do a power of a product, and this is one that a lot of people make mistakes with, so I'll show you an example of this in a second. Make sure you raise each side to that power. So B is raised to the n as well as C is raised to the n, and the same thing would happen if that was in a fractional form. So if you take a look at the example that we have below, I'll start with the basic one, a to the third times a to the second. Two things with the same base. I'm going to use that multiplication rule of keeping the base the same and adding those powers together. So that's how I end up with a to the fifth. Just to kind of throw back to why does that come out to be a to the fifth? Remember, a cubed is basically 3a's multiplied together. A squared is basically 2a's multiplied together. And if I combine them all together, they become a raised to the fifth power. Now, if it happened that I'm dealing with, more than one thing that's being multiplied, not that you have to do this, but you can in your mind think of this as 3 times 2, and then a squared times a, and then b times b, and then c by itself. So therefore, as I multiply, obviously 3 times 2 is 6. A squared times a becomes a cubed because I'm adding my powers. B times b becomes b squared, and then c is obviously by itself because there's nothing to combine it with. If I now go to that power to a power rule, so you'll notice the difference between something like number 1 and number 5. In this case, I am multiplying two things that have the same base, whereas in number 5, I'm raising a to the third to the second power. So a different way you might want to think of this is to think of it as a to the third times a to the third, or two things of a to the third. So if I use my multiplication rule, this would become a to the sixth because I'm adding 3 plus 3. Or if I use that power to a power rule, a cubed to the second power, I would multiply 3 times 2, and that's how it would end up directly with a to the sixth. Now this is a case where a lot of people make mistakes, so I want you to take a look at number 6, and I gave you a little hint as to a way you could write this out if you think you might make a mistake with this. When you are raising what's called a monomial to a power, which is what we have here, 3ab squared is a monomial. When you raise that to the second power, technically what you're doing is 3ab squared times 3ab squared. Now you have to make sure you remember to raise everything to the second power, and the thing that most people forget is usually the 3. So 3 has to be raised to the second power, a has to be raised to the second power, and b squared has to be raised to the second power. Okay, and again, the mistake that most people make is they either only raise the b squared to the second power or they forget about doing it with the 3. So if you think you might make a mistake, just write it out like this, 3ab squared times 3ab squared. As I simplify, 3 squared is 9, a squared stays a squared, and b squared to the second power, that's a power raised to a power, becomes b to the 4th. The last rule that we had mentioned was the one where you're dividing things that have the same base. So in a similar fashion to the way that you would add if you're multiplying, if you're dividing, you subtract. So if you take a look at number 8, I have the same base. I'm raising to the 7th power and to the 3rd power, so this is going to become a to the 7 minus 3 because I'm dividing, and eventually that comes out to be a to the 4th. To give you a visualization of why that looks like that, a to the 7th would basically be 7 a's on the top, a to the 3rd would be 3 a's on the bottom. As I cancel out from the top and bottom, I end up with 4 a's remaining on the top, hence why my answer comes out to be a to the 4th. And last but not least, if I happen to have a number of things that are in the top and in the bottom, similar to the way that I multiplied each thing individually, I'll also, divide each thing individually. Basically, what you're going to do is you're going to subtract the powers, and wherever you have something remaining, that stays either in the top or in the bottom. So I'm actually going to start with the y and z, and then I'll come back to the x for just a second. So if you notice, I have y squared divided by y. So that would be subtract 2 minus 1, because I'm subtracting my powers, and that would leave me with a y to the 1st in the top, because 2 is a bigger power than 1. If you take a look at x over x squared, x and x squared, technically I'm still going to subtract my powers and get x to the 1st, because one power is 2 and the other power is 1. But because the x squared technically is bigger, that leaves me with that x to the 1st in the bottom. So in a similar fashion, if you look at the last one, z to the 9th and z to the 5th, don't worry about where they're located, just do 9 minus 5. But the fact that z to the 9th is bigger, that's why z to the 4th, which is what you get when you subtract 9 minus 5, stays in the bottom. And again, if you need a visual, you can go back to what this visual is that I did in number 8 with stuff you have in number 10. But I think you should be fine if you just subtract, and then wherever the bigger power is, that's where your remaining part gets left over. Okay, hope you enjoyed this recap from algebra. Feel free to go back and try those other problems if you feel like you need a little more practice.